NENOMATICA, where mathematics meets YouTube excellence. In this example, we solve for the parameter m so that the difference between the roots of the quadratic equation x squared plus x plus m equals 0 is exactly 2. We'll proceed with a clean, step-by-step plan. For the quadratic ax squared plus bx plus c equals 0, here a equals 1, b equals 1, and c equals m. The discriminant delta equals b squared minus 4ac, so delta equals 1 minus 4m. The distance between the two real roots is given by the formula. Absolute value of x prime minus x double prime equals the square root of delta divided by the absolute value of a. We are told this distance is 2, so 2 equals the square root of 1 minus 4m. Now square both sides to remove the square root. That gives 4 equals 1 minus 4m. Move terms to isolate m. So m equals negative 3/4. Let's verify. Substitute m equals negative 3/4 into the quadratic and compute the roots. The equation becomes x squared plus x minus 3/4 equals 0. The roots are negative 1 plus or minus 2 all over 2, which are 1/2 and negative 3/2. Their absolute difference is 2 as required. Therefore, the unique value of m that makes the distance between the two roots equal to 2 is negative 3/4. We have the quadratic ax squared plus bx plus c equals 0. Its roots are x1 and x2. The given relation is x1 minus x2 plus x1 x2 equals 0. We must show that one of the roots equals open parenthesis c minus b close parenthesis over 2a. To use the relation, we recall two facts. By Vieta's formulas, the product x1 x2 equals c over a, and from the quadratic formula, the difference of the roots x1 minus x2 equals square root of capital delta divided by a, where capital delta equals b squared minus 4ac. Now we substitute these into the given relation, replacing x1 minus x2 by square root delta over a, and x1 x2 by c over a gives square root delta over a plus c over a equals 0. Clear the denominator by multiplying both sides by a. We get square root delta plus c equals 0. Hence square root delta equals negative c. Next recall the quadratic formula. Each root equals negative b plus or minus square root delta all over 2a. Substituting square root delta equals negative c gives x equals fraction negative b plus or minus left parenthesis negative c right parenthesis over 2a, which simplifies to x equals fraction negative b minus or plus c over 2a. Therefore, the two roots are as follows. One root is open parenthesis c minus b close parenthesis over 2a, and the other is open parenthesis negative c minus b close parenthesis over 2a. In this example, we are given a quadratic with roots alpha and beta. We will evaluate the expression. Open parenthesis alpha cubed minus 2 alpha squared close parenthesis times open parenthesis beta cubed minus 2 beta squared close parenthesis using Vieta's formulas. Step 1. Use the sum and product of roots. 4ax squared plus bx plus c equals 0. The sum s equals negative b over a, and the product p equals c over a. Here, a equals 2, b equals negative 4, and c equals negative 1. Therefore, s equals 2, and p equals negative 1/2. Step 2. Factor each bracket. Alpha cubed minus 2 alpha squared equals alpha squared times alpha minus 2. Similarly, beta cubed minus 2 beta squared equals beta squared times beta minus 2. Step 3. Rewrite using s equals alpha plus beta and p equals alpha beta. Expand the binomial alpha minus 2 times beta minus 2, which equals alpha beta minus 2 times alpha plus beta plus 4. That is p minus 2s plus 4. So the whole expression becomes alpha squared beta squared times p minus 2s plus 4, which is p squared times p minus 2s plus 4. Step 4. Substitute the values s equals 2 and p equals negative 1/2. We obtain p squared times p minus 2s plus 4 equals open parenthesis negative 1/2 close parenthesis squared times open bracket negative 1/2 minus 4 plus 4 close bracket, which simplifies to 1/4 times negative 1/2 equals negative 1/8. Therefore, the value of the expression is negative 1/8. Let x1 and x2 be the roots of the equation. Our condition is x1 squared minus x2 squared equals 16. Because a difference of squares factors, we rewrite the condition as left parenthesis x1 minus x2 right parenthesis times left parenthesis x1 plus x2 right parenthesis equals 16. From Vieta's formulas for ax squared plus bx plus c equals 0, the sum of roots is negative b over a, and the product of roots is c over a. Here a equals 1, and b equals negative 2, so the sum s equals 2. The product p equals m. Also, the distance between the roots in one dimension is the square root of the discriminant divided by a. So absolute value of x1 minus x2 equals square root of delta over a. For our quadratic, delta equals b squared minus 4ac, which is 4 minus 4m. Now substitute into the factored condition. We have the square root of 4 minus 4m multiplied by the sum 2 equals 16. Divide both sides by 2 to get square root of 4 minus 4m equals 8. Simplify inside the square root as 2 times the square root of 1 minus m equals 8. Therefore, the square root of 1 minus m equals 4. Square both sides to get 1 minus m equals 16, and finally m equals negative 15. As a check, the discriminant becomes 4 minus 4 times negative 15, which is 64 non-negative. Then the absolute difference of the roots is 8, and multiplying by the sum 2 gives 16, matching the requirement. Therefore, the required value of m is negative 15. In this example, we will determine m and the roots of a quadratic using the sum of reciprocals of the roots. The equation is x squared minus mx plus 36 equals 0. We are told that 1 over x1 plus 1 over x2 equals 5 over 12. We will first connect this condition to the coefficients using Vieta's formulas, then solve for m, and finally find the two roots. By Vieta's formulas for a monic quadratic, the sum of the roots equals m, and their product equals 36. The sum of reciprocals is therefore the sum divided by the product, which is m over 36. Now set this equal to the given value 5/12. That gives m over 36 equals 5 over 12. Multiply both sides by 36 to get m equals 36 times 5 over 12, which simplifies to m equals 15. Substitute m equals 15 back into the quadratic. We have x squared minus 15x plus 36 equals 0. To factor, we need two numbers whose product is 36 and whose sum is 15. Check factor pairs and highlight the correct one. So the factorization is x minus 3 times x minus 12 equals 0. Setting each factor equal to 0 gives the roots. X equals 3 and x equals 12. As a quick check, plug into the reciprocal condition. 1/3 plus 1/12 equals 4/12 plus 1/12, which is 5/12. Everything is consistent. Example, we are given a quadratic with parameter a and a condition on its two roots. Determine the value of a such that the roots satisfy the given relation. Step 1. Use Vieta's formulas to express the sum and product of the roots in terms of a. For ax squared plus bx plus c equals 0, the sum of roots is negative b over a, and the product is c over a. For our coefficients, this gives s equals 1 minus 2 over a, and p equals 2 minus over a. Step 2. Start from the given relation and combine over a common denominator. We write the sum as a single fraction. Expand the numerator carefully. Terms cancel, and the numerator becomes 2 times x1 x2 minus 2. Step 3. Express the denominator using s and p. The product x1 plus 1 times x2 plus 1 equals p plus s plus 1. Substitute this into the fraction to get 2p minus 2 over 1 plus s plus p equals 1/2. Step 4. Replace s and p by their expressions in a and solve. Substitute s equals 1 minus 2 over a and p equals 2 minus over a. Cross multiply to get 2 times 2p minus 2 equals 1 plus s plus p. That simplifies to 4 times 2 minus I over a minus 4 equals 3 minus 2 over a. Multiply both sides by a and collect like terms to find a. In this lesson, we will solve an algebra puzzle using Vieta's formulas. we are told that m and n are the roots of x squared plus ax plus 1 equals 0. Also r and s are the roots of x squared plus bx plus 1 equals 0. We want to simplify the expression a equals open parenthesis m minus r close parenthesis, open parenthesis n minus r close parenthesis, open parenthesis m plus s close parenthesis, open parenthesis n plus s close parenthesis, in terms of a and b only. Here is the problem written down. We will also record the sum and product of roots for each quadratic. First, group the first two factors and the last two factors. Notice that m minus r times n minus r expands as r squared minus m plus n times r plus m n. Likewise, m plus s times n plus s expands as s squared plus m plus n times s plus m n. Now substitute m plus n equals negative a and m n equals 1. This turns the first bracket into r squared plus a, r plus 1, and the second bracket into s squared minus as plus 1. Next, we multiply out these two quadratics carefully. Now we regroup in terms of our s and r plus s because we know their values from the second quadratic. Collect the r squared, s squared as our s squared, the mixed r s terms, and the r plus s square. Then substitute our s equals 1 and our plus s equals negative b. The negative a r cancels with positive ar, and positive as cancels with negative as. The constants 1 minus 2 plus 1 also cancel, leaving simply b squared minus a squared. Therefore, a equals b squared minus a squared. In this lesson, we will express a symmetric product in terms of the coefficients of two quadratic equations. We are told that alpha and beta are the roots of x squared plus px plus q equals 0, and that gamma and delta are the roots of x squared plus ax plus b equals 0. We want to compute the value of the product, open parenthesis, alpha minus gamma, close, open parenthesis, beta minus gamma, close, open parenthesis, alpha minus delta, close, open parenthesis, beta minus delta, close, and simplify it using p, q, a, and b. First, write the Vieta relations for each quadratic. 4x squared plus px plus q equals 0. The sum alpha plus beta equals negative p, and the product alpha beta equals q. 4x squared plus ax plus b equals 0. Gamma plus delta equals negative a, and gamma delta equals b. Now group the large product as two factors. Think of z as gamma for the first factor and delta for the second. For a placeholder z, expand the expression alpha minus z times beta minus z. It equals z squared minus the sum alpha plus beta times z, plus the product alpha beta. We will apply this with z equals gamma and z equals delta. Use alpha plus beta equals negative p and alpha beta equals q. Each bracket becomes gamma squared plus p gamma plus q, and delta squared plus p delta plus q. Because gamma and delta satisfy x squared plus ax plus b equals 0, we have gamma squared equals negative a gamma minus b, and similarly for delta. Replace gamma squared and delta squared to linearize each bracket. Set u equals p minus a and v equals q minus b for a clean expansion. Then the product is u squared times gamma delta plus uv times gamma plus delta plus v squared. Substitute gamma delta equals b and gamma plus delta equals negative a. Finally, substitute u equals p minus a and v equals q minus b and expand carefully. Collect like terms to obtain the simplified expression. Therefore, the value of the product is b squared minus a bp minus a pq plus a squared q minus 2q b plus p squared b plus q squared. In this lesson, we will derive a clean condition on the coefficients a, b, and c for a quadratic equation to have two real roots whose difference is exactly 1. The problem states, for the quadratic ax squared plus bx plus c equals 0, if x1 minus x2 equals 1, show that b squared minus 4ac equals a squared. First, let's visualize what it means for the roots to be 1 unit apart on the number line. We'll mark x2 at some point r, and x1 at r plus 1. The distance between them is exactly 1. Now recall the quadratic formula. The two roots are negative b plus or minus the square root of delta, all over 2a, and delta, the discriminant, equals b squared minus 4ac. if we take x1 as the plus branch and x2 as the minus branch, the difference x1 minus x2 becomes the square root of delta divided by a. Let's write that cleanly. But we were told that x1 minus x2 equals 1. So we set square root of delta over equal to 1. That means square root of delta equals a. Squaring both sides gives delta equals a squared. Finally, substitute the discriminant delta equals b squared minus 4ac. We obtain b squared minus 4ac equals a squared. This is the precise relationship among a, b, and c for the roots to differ by 1. Let's verify with a quick example. Pick a equals 2, so the condition says the discriminant must be 4. Choose b equals 6. Then c must be 4, so that b squared minus 4ac is 36 minus 32, which is 4. The quadratic 2x squared plus 6x plus 4 equals 0 has roots negative 6 plus or minus 2 all over 4. That gives x1 equals negative 1 and x2 equals negative 2. Indeed, their difference is 1. Example. We will find a relation between the coefficients b and c for the quadratic x squared plus bx plus c equals 0 when its two roots are consecutive integers. Strategy. We will use the idea that for any quadratic, the distance between its two roots equals the square root of the discriminant divided by a. Here a equals 1, so the distance equals the square root of b squared minus 4c. For consecutive integers, that distance must be exactly 1. Visualize the roots on a number line as r, and r plus 1, two adjacent ticks 1 unit apart. The root gap identity says gap equals square root of b squared minus 4ac divided by absolute a. For our equation a equals 1, so the gap equals the square root of b squared minus 4c. Since the gap is 1, set the square root of b squared minus 4c equal to 1. Now square both sides to eliminate the square root. We obtain b squared minus 4c equals 1. This is the required relation between b and c. Cross-check. Let the roots be r and r plus 1. Then the sum equals negative b, which is 2r plus 1. And the product equals c, which is r times r plus 1. The discriminant equals the square of the difference between the roots, which again gives 1 and confirms the same relation. Quick numeric check. Choose r equals 2, and r plus 1 equals 3. The polynomial with those roots is x squared minus 5x plus 6. Here b equals negative 5, and c equals 6. Compute b squared minus 4c equals 25 minus 24 equals 1, which matches the relation. Final answer. 4x squared plus bx plus c equals 0 to have two consecutive integer roots. The coefficients must satisfy b squared minus 4c equals 1. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.